Hi, I'm Ben Zorn, and I'm going to be talking about spreadsheet understanding, including two projects, Jura and Excellent, which is joint work with Alex Polozov, Emery Berger, and Dan Bowery. So the thing about spreadsheets is that they're used by millions of people. They're used to make important decisions like financial decisions, economic decisions, etc. And many of these spreadsheets actually have errors. And in fact, what we see, if you look at the news, the Reinhart Rogoff spreadsheet, which is a spreadsheet developed by Harvard economists, was used to justify a policy of austerity, including in countries like Greece and in the United States. The Reinhart Rogoff spreadsheet is a very complex spreadsheet that involves looking at the history of debt in countries over a period of hundreds of years. And what we find with the Reinhart Rogoff spreadsheet is that it actually had important errors that led the authors to draw the wrong conclusions. So the key message in this is that spreadsheets are used by many people to make important decisions, and what we're trying to do is bring tools to the spreadsheet users to help them understand their spreadsheets more easily and help them make better decisions based on them. So let me start with our first tool, which is called Excellent. And what I'm showing here is actually the Reinhart Rogoff spreadsheet, which was originally developed by these Harvard economists. And in particular, the important sheet here is the summary sheet, which involves, as you see in the rows, a number of countries, US, UK, etc., 24 different countries, and information about the historical debt and indebtedness of these countries related to their economic growth. And if you look at the spreadsheet, it looks very complicated. In each of these countries, if you break it out, like the US, has much data, many rows of data for many years, starting in 1791 in the United States. But if you look at the summary, you can imagine why it would be hard as a user of this spreadsheet to understand whether it's correct or not. And so one of the things we've done in our technology, we have a technology called Excellent, which allows us to very quickly understand the structure of the spreadsheet using statistics. So in particular, if I just press this button, Reveal Structure, on the Reinhart Rogoff spreadsheet, the colors are going to encode information to the user about the things that are happening on the spreadsheet. In particular, the gray means that I have data, just regular data, but the gray means it's being referenced by some formula in the sheet. The yellow is unusual because the yellow means it's a data that's on the sheet that is not being referenced by a formula. And what we see immediately in this presentation is that this range of data is not being used by any formula. And if you'll drill down more closely, what you find is that the formula here, which is computing an average, actually fails to include this range of cells in the average. And this is the bug in the Reinhart Rogoff spreadsheet. In particular, the countries Canada, Belgium, Austria, and Australia are not being counted in the average, and in fact that leads them to an incorrect conclusion. So what we have with Excellent is a tool that allows you to very quickly understand what's going on in the spreadsheet and make important decisions. And as you can imagine, the individuals who created the spreadsheet originally, Reinhart Rogoff, if they had had this tool, they wouldn't have made this very important error, which led to incorrect conclusions. So we can also look at particular other sheets in the spreadsheet, for example, the United States. And if you say Reveal Structure on this one, you see different colors, again, showing that different columns are being computed different ways. But one thing that's interesting is we have here essentially what we call a suspiciousness index that tells you that this particular range of cells, and if I click on it, it will take me there. This range of cells is suspicious. And in particular, what you see here is that this cell, the very first cell, K7, is actually being computed by a different formula than the cells below it. So again, very quickly we can find a bug in the spreadsheet, and again, this is the original spreadsheet, so the authors did not actually understand. Okay, so that's Excellent. I encourage you to try it out. It's actually available online. Here's another technology. So one of the things that we're trying to do in our research is to understand spreadsheets because they contain both data, formulas, which is code, and presentation. Things like what a human is trying to communicate to another human. So this sheet in particular is an example of this. The user has headers. The user has formatted the data in such a way that there are blank rows and columns to help with white space. And as a result, where this table starts and ends is actually not completely obvious. So it's not explicit in the presentation. So what we've developed is a technology called Jura, which is essentially trying to find the tables in a given sheet, which is basically an arbitrary bounding. So Jura uses a technology based on neural networks that looks at every cell and asks the question, the neural network asks the question, is this cell the corner of a table? And so what we have is we have an ability to show what the neural network thinks about the corners. And what we're seeing here is that the neural network is saying this corner, and this corner all look like bottom right corners, right? That's what the blue encodes. This corner up here looks like a top left corner. So what it's trying to do is understand the overall structure of the sheet based on individual cells and what it thinks are the corners. Once it understands the whole, like a holistic view of all the cells, our technology Jura can then basically find the table. And so we can say, show me all the tables on the sheet. And what we see here now is it understands that this is the table. Note, for example, that this particular part of the table, which is just an annotation, is not counted by Jura as part of the table, which makes sense because it's really not, it's more like, it's more like a footnote. So what we've shown here is two different technologies using two different techniques, statistical analysis and neural networks that help us understand spreadsheets and ultimately are going to empower users to quickly and effectively make use of their spreadsheets and come to correct conclusions. Thank you for your time.